Okay, a review of what's going to happen in the labs for food science and chemistry, which is a little bit complicated based on the current situation we're in. So there's two categories of lab practicals in brackets. The ones in reds are ones we'll do in masterclasses. You won't be writing them up for the assignment, though we will be working through the results. The other two, maillard reaction and polyphenol oxidase in apples, are virtual labs which you will be given the results, a result set, and you write these up for the assessments. If you look at the model compared to the normal labs full access model we've done without coronavirus, it's quite a significant difference, obviously, but rather than doing lab practical work as normal, you're provided with simulated results. Everything else is the same. So apart from not having actually done the lab work, which is a big issue, and I don't pretend it isn't, we will give you the results. Okay, so masterclasses, we'll get them out of the way first. The difference is you'll be working individually in individual workstations. Previously in the past, we worked in lab, you've normally worked in small teams. That won't be happening. Be collecting the results during the lab. We're doing HPLC and ICP-MS, so the technicians will give the results either directly or they'll email them up into Blackboard. We'll have a look at them, and I and the technician staff will be around, though everyone will be working in a socially distanced model. At the moment they're scheduled to be on these two dates. There are a couple of issues in my timetable which need to be sorted out, so the first one might change possibly, but I will let you know as soon as I know. Okay, yeah, so this is what the sort of things you should normally do. Read the lecture notes around the topics, think about why and how questions, why we're doing this, how we're doing it, why do we care about this, how we're doing it. Also the risk assessment. For the master classes, you'll be asked to handwrite the cost summaries in the lab book as usual. They can be found in the usual places. So the cost document, as we know, is quite a long risk assessment, but what we're mostly interested in from our point of view is the conclusions in terms of hazards and handling. So it's the sort of stuff you will have done before. Handwrite your summaries in your lab book before starting work to demonstrate that you have read them. Yeah. They're available in the labs, and we'll also make them available in Blackboard in various places. Okay, recording information in the lab. Again, just reiterating what we've done in the past. Write them in your lab book, not in your hand, which you might take away and wash without recording your information somewhere else. You always use your lab book, so if you're going to weigh something in the balance room, take your lab book with you. Yeah, be careful about what you record. So here's something which somebody might have recorded in a lab book and it's not particularly useful, it's just a bunch of numbers. This is much more illustrative of what's actually happened. We've talked about significant figures in the past, so I'm not going to reiterate that again. So summarising results, this is a typical HPLC chromatogram, of which is only a small part of the information is relevant to us. So what we normally do is summarise in the table. So in this case we've got a table of first 4 standards and then 3 samples with their peak area in millivolts. Again, we'll talk about that when we're doing the labs. So the virtual labs, which you are going to be writing up, you'll be given some simulated lab results. So what I've got some good quality sets of data, and I'm going to use an Excel function called run between to generate, again, good sets of data, but not identical for each of you. You'll each get your own set of data, which will be sort of handing out randomly. And that'll be what you base the results section of your report on. Usual lab report structure, with details there of what you would normally put in. So it's a standard scientific report. Usual Harvard standard citation for referencing, which would be mostly in the introduction, but you may want to in your discussion, in the body of the essay, which we'll talk about in a second. Look at some standard sources to compare your results to. Yeah, so the cover page, information about you, the module, and what you've done. Table of contents should be based on headings and page numbers and should be set to update automatically by methods which I have talked about in the past, and I think if I don't have the link here, I'll point you to the link. Text format, 11 to 12 point Arial, 1.5 line spacing, and use headings and subheadings, which are quite useful. They demonstrate you thought about organising your work, and they make the work easier to read, and also they allow you to update your table of contents automatically. So the start of the report, your due diligence, your title and your aim, team members, which in this case is just you, your cost information, chemicals used list, the equipment list, which again you'll be provided with this information. The body of the report is a typical scientific report, so we start with an introduction, the why and how, what results people have got perhaps in the past, your methods, your results, calculations and discussions arising from your results, critical analysis, how could we improve this? There are a number of ways which we will talk about in the tutorials, and your references and any appendices, which normally we use for these is where you put your raw results. So as we saw early on, you've got a bunch of raw results from your HPLC. They will be put in the appendix. I don't want to see them in the main report. I just want to see summaries in the main report. Yeah, okay, topic review. For your assignment introduction, so one of them is going to be the Maillard reaction. So what is the chemical base of the Maillard reaction? I expect a good detailed description of that. And why do we care from a food chemistry point of view? And then a technique review, which in this case is spectroscopy. There are videos available, and you review the method sheets and various other things. And also you would include your lab safety information. Yeah, so the aim of the experiment, the title is one thing, but what's the experiment trying to achieve? So we've got an example here, which you may remember from last year. A generic title is vitamin C in orange juice, but our specific aim is to determine the concentration of vitamin C in orange juice using HPLC. So it's a bit more detailed. It tells us much more about what we're actually doing. So the title is one thing, but you will also have to have an aim as well. You should obviously be thinking about hypotheses. Again, we'll talk about this a bit in the tutorials. Science works on the basis of a null hypothesis. We are trying to disprove a proposition. So a proposition here might be that if we increase the concentration of sodium bicarbonate, it does not increase browning. Now many of you will say, well, of course it does. That's what we observe. Well, that's the alternative hypothesis. The results may well support this. In that case, we would say our results supported the alternative hypothesis that increasing the concentration of sodium hydrocarbonate does increase browning, so we reject the null hypothesis and accept the alternative hypothesis. This is how science works. We always start by assuming the null hypothesis, that our proposition isn't going to work, and then we seek evidence to disprove that hypothesis. Okay. Standard lab format. I've already talked about this a little bit. Maximum of 2,000 words, excluding headings, tables, references and appendices. Presented professional format. I've talked a number of times about things like automatic table of contents. If you want to refer again to my video on this, there's a link through to it. And there's a typical front page which I've removed the personal information from. Obviously, you would have your personal information on this. The marking scheme is the standard marking scheme, which you are very familiar with for lab reports. As you know, I go into a little bit more detail, so if you sort of go through this and look at the sort of things I'm expecting, it will ensure that you put in all the information you need to put in. That's okay, that's all for now.